Welcome to iLecture Online. Our next example deals with a factor situation where we have two machines and we're trying to produce drills and saws. And you can tell that on machine 1 you need 3 hours to produce drills, and on machine 2 you need 4 hours to produce drills. So it takes a total of 7 hours on the two machines. And for saws we need 4 hours on machine 1 and 2 hours on machine 2. And notice the machine is only available for 12 hours on each day. So the idea would be, how many of each can we produce in a single day? And we've already got a little head start on it. We're going to let x equal the number of drills produced and y is equal to the number of saws produced. So now we need some inequalities, because there's a maximum you can produce, but you can produce less, and we want to take a look at that. So how can we do this? Well, we are limited by the number of hours on each machine. So we can then set up an inequality for each machine. For machine 1, we cannot have more than 12 hours used. And 3 times x would be the number of hours we use machine 1 for drills, plus 4 times x, 4 times y, because y is the number of saws produced. That's the total number of hours used on machine 1 for saws, and that has to be less than or equal to 12. We cannot exceed 12 hours. We do the same for machine number 2, and so we have 4 times x plus 2 times y must also be less than or equal to 12. So this is machine 1, this is machine 2, which becomes inequality 1 and inequality 2. We have 2 more restrictions because we cannot produce negative numbers, so x must be greater than or equal to 0 and y must be greater than or equal to 0. So that's inequality 3 and inequality 4. So we have 4 total inequalities determining what we can do here. So in order to graph that, we're going to find the equivalent equations. So that is 3x plus 4y equal to 12. And of course, we want to put that in the format y equals mx plus b. Like this. That means that 4y is equal to minus 3x plus 12. Divide everything by 4, you get y equals minus 3/4 x plus 3. So there's our equation number 1 that corresponds to inequality number 1. We do the same for the second inequality. So end up with 4x plus 2y is equal to 12, or 2y equals minus 4x plus 12, or y equals minus 2x plus 6. And there's our equation number 2. Notice these present the boundaries of the regions that we're interested in, and since we have less than or equal to for both, we have solid lines signifying those boundaries. So let's go ahead and graph those. Here's our y-axis, our x-axis. We have minus 2x plus 6, so let's make this plus 6 right here. Minus 2, that's a pretty steep curve going downward like this. This hits it at 3 for x, 6 for y. And of course goes down the other direction like that. And for that one, we are plus 3 here, and the slope isn't quite as steep. We go down 3 and over 4, so that means that this line will look like this. We cross at 4 right there, we cross at 3 right there. This would be 3, that's 6. Okay, and we should label them. So this is line number 1, this is line number 2. And now we want to find all the regions that satisfy the inequalities. So first of all, we can go to 3 and 4. We want to be big, x bigger than 0, y bigger than 0. Y bigger than 0 means everything above there is valid, below there is not, so we can get rid of what's not valid, like that. And everything to the left of the y-axis, that means x would be negative there, so this is also invalid. We cannot produce in negative quantities. Okay, now we pick test point, pick the point 0, 0. And let's plug those into the 2 inequalities. So let's start with inequality number 1. We plug in 0 for x and 0 for y. Is 0 plus 0 less than or equal to 12 question mark? And the answer is yes, it is. So that means 0 is on the correct side of line number 1. That means this is the correct side, that's the wrong side, so we want to get rid of the other side. Of course, it's a good idea to put the word yes there to indicate that yes, it satisfies. Then for inequality number 2, again we plug in 0 for x and 0 for y, is 0 plus 0 less than or equal to 12, question mark. The answer, of course, is yes again. That means we're on the correct side of this line. That means the other side is not correct. We want to get rid of that, which means that this is the region in which we can produce. In other words, we can produce 3 of y, and y represents drills. That means 0 of x, which is saws. We can produce 3 drills and 0 saws, or it can produce 3 saws and 0 drills, or we can produce a combination of the two. If you want to know what this point is, because that's one of the production points we can be at, we want to solve the two equations simultaneously. We want to set those to equal to each other. So we set y1 equal to y2. y1 is minus 3/4 x plus 3. Set that equal to minus 2x plus 6. Move the 2x over here, the 3 down there. So we have minus 3/4 x plus 2x is equal to 6 minus 3. I'd get rid of the 4 in the denominator, multiply everything by 4. So we have minus 3x plus 8x equals 24 minus 12. Or 5x is equal to 24 minus 12, which is 12. Or x is equal to 2.4. Well, that doesn't quite work. We can't really work all the way up to here. Theoretically, yes, but of course we can't produce a fraction of a drill or fraction of a saw. I guess we could, and then continue on the next day. That might be a possibility. But anyway, that's how we realize what the region is in which we can produce drills and saws using those two machines in any given day. And that is how it's done.